Good morning, dear students. Hope all of you are fine. I am also fine. Today, I am going to discuss about some creative questions of chapter 4, and this is the thermochemical part of chapter 4 and also the acid base part of chapter 4. Look at the whiteboard. Basil A contains 0.1 molar ethanoic acid. You know that ethanoic acid is also known as acetic acid, and the volume of acetic acid is 160 ml, and the dissociation constant of acid is 1.8 into 10 to the power minus 5, and Basil B contains 0.15 molar sodium hydroxide, and the volume of sodium hydroxide is 60 ml, and Basil C is sulfuric acid. The first question is calculate the pH value of solution of Basil A and Basil B. So come to the point. Question number 1. Students, you can understand easily ethanoic acid is a weak acid. Normally, if in the question pH value is asked and also the dissociation constant of acid is given, in that case you should have understand that this is actually weak acid. Otherwise, you know that normally the organic acids are weak acids. However, in case of weak acid, I have to use Ostwald's dilution law for the determination of the pH value. So, from the Ostwald's dilution law, we know that degree of dissociation alpha is equal to root over Ka by C. Here degree of the value of Ka is equal to 1.8 into 10 to the power minus 5, and the concentration of acetic acid is 0.1 molar. Then I have to put those two values here. 1.8 into 10 to the power minus 5 divided by 0.1 is equal to 0.0134. This is the value of degree of dissociation of ethanoic acid. And then we know that the molar concentration of H plus ion is equal to alpha C. Here the value of alpha is 0.0134 and C is 0.1. It is given in the stem. So the molar concentration of H plus is equal to 1.34 into 10 to the power minus 3. And dear students, we know that pH is equal to minus log molar concentration of H plus ion is equal to minus log 1.34 into 10 to the power minus 3 is equal to 2.872. This is the answer. And this Ostwald's law is applicable only for weak acid or weak base. And the second part of the question, pH value, calculation of pH value of Basil B. Basil B contains sodium hydroxide. Sodium hydroxide aqueous solution ionizes to produce sodium ion and hydroxide ion. Here POH is equal to minus log molar concentration of OH minus ion is equal to minus log molar concentration 0.15. It is given molar concentration of hydroxide ion is equal to 0.15 molar. So the POH is equal to 0.823. Students, we know that pH plus POH is equal to 14 or pH is equal to 14 minus POH is equal to 14 minus 0.823. So pH is equal to 13.177. This is the answer of question number 1. And question number 2, if a small amount of acid or base is added with the mixture of A and B, then how the pH will change? Students, first I have to define about the mixture of A and B. Actually, I would like to say you mixture of A and B, is it a acidic buffer solution or basic buffer solution? First I have to analyze it mathematically. Okay, students, from this calculation I can say that 9 ml 1 molar sodium hydroxide reacts with 9 ml 1 molar acetic acid. So first I have to write the reaction. Acetic acid plus sodium hydroxide is equal to sodium acetate plus water. Here actually 9 ml 1 molar acetic acid reacts with 9 ml 1 molar sodium hydroxide to produce 9 ml 1 molar sodium acetate salt. So after reaction, the remaining ethanoic acid or acetic acid is, after reaction, the remaining solution is equal to 16 minus 9 ml 1 molar acetic acid is equal to 7 ml 1 molar acetic acid. So the remaining acetic acid is mixed with the produced salt, sodium acetate, to make acidic buffer solution. Acidic buffer solution. So actually, students, already you have to understood that in the question number 2, it is indicated acidic buffer solution. I mean the mechanism of acidic buffer solution. Now I am going to discuss about the mechanism of acidic buffer solution. Acidic buffer solution, ethanoic acid and sodium ethanoate is present, and here ethanoic acid ionizes to produce ethanoate ion and H plus ion, and sodium ethanoate ionizes to produce also ethanoate ion and sodium ion. Students, you can see that here the first reaction I have written the reversible sign because it is a weak acid, and the ionization process exists at the equilibrium state, but sodium ethanoate, it is a strong electrolyte, I mean its level very highly, and that's why it ionizes completely in the aqueous solution. That's why I have shown here the one-way direction reaction. However, students, if I add a small amount of acid, the H plus ion of acid reacts with the acetate ion of acidic buffer solution to produce ethanoic acid. Ethanoic acid is a weak acid, that's why it remains unionized, and due to the common ion effect, ethanoic acid is also unionized. As a result, the pH value of acidic buffer solution remain unchanged after a small amount of acid is added. Now, if I add a small amount of base, the hydroxide ion of base combines with H plus ion of acidic buffer solution to produce water. At the same time, the unionized ethanoic acid at the equilibrium state reproduces same amount of H plus ion. As a result, the pH value of acidic buffer solution remain unchanged after addition a small amount of base. That's all about the mechanism of acidic buffer solution, students. Now look at the third question. Analyze the differences of heat of neutralization of the mixture of A and B solution and also B and C solution. Students, already you have understood that the solution A contains a weak acid and solution B contains a strong base and solution C contains also a strong acid. Now I have to understand that what is heat of neutralization. Students, Basel A plus B, the occurred reaction is ethanoic acid or acetic acid, sodium hydroxide, sodium ethanoate plus water. The reaction between acid and base is known as neutralization reaction. If in our neutralization reaction 1 mole of water is produced, then the evolved heat is known as heat of neutralization. So, here the heat of neutralization delta H is equal to minus 55.14 kilojoule. Students, here actually ethanoic acid is a weak acid, that's why it ionizes partially. I mean, if you take 1000 ethanoic acid molecule in the sufficient amount of water, only 4 molecules of ethanoic acid ionize completely and the remaining part of the ethanoic acid remain unchanged. That's why I can say that in the aqueous solution ethanoic acid ionizes partially. To produce ethanoic acid ionizes partially to produce ethanoate ion and H plus ion. Sodium hydroxide ionizes completely to produce sodium ion and hydroxide ion. Here actually ethanoate ion and sodium ion exist in the reaction system as spectator ions. Only the H plus ion and hydroxide ion combine together to produce water. Here actually in the 1 mole water formation reaction, the delta H value is actually minus 57.34 kilojoule, but this heat of neutralization is used to break the remaining amount of ethanoic acid which was unionized initially, and in this work 2.2 kilojoule heat is used. As a result, the delta H value is decreased and it becomes at minus 55.14 kilojoule. It is noted that the heat of dissociation of ethanoic acid is 2.2 kilojoule. Students, now I am going to discuss about the heat of neutralization of sodium hydroxide and sulfuric acid. Here sulfuric acid is a strong acid, that's why it ionizes completely to produce huge amount of H plus ion and sulfate ion. Students, I have given here half mole of sulfuric acid. It is given just to make it balance, and I have used here half because to be fixed the amount of water is in 1 mole, because heat of neutralization is calculated for only 1 mole of water. That's why I have to fix it at 1 mole plus sodium hydroxide, sodium ion and hydroxide ion to produce. Here actually sodium ion and sulfate ion exist in the reaction system as spectator ion. Only hydrogen ion and hydroxide ion combine together to produce water. Students, here actually H plus ion and OH minus ion combine together to produce 1 mole of water, and the delta H value is minus 57.34 kilojoule approximately. It is noted that this heat of neutralization does not use for the ionization of any further of acid or base like the previous one, I mean acetic acid. That's why in this case heat of neutralization is minus 57.34 kilojoule, heat is fixed. That's why the heat of neutralization of the reaction of A plus B is minus 55.14 and the reaction between B plus C is minus 57.34 kilojoule. This is only for the strength of acid or base. Here actually the acid is weak acid and the base is strong base, but in case of BC both of the acid and base are strong acid and strong base. Dear students, I would like to repeat you again. Strong acid or strong base means both of them ionize in the aqueous solution completely, but in case of weak acid or weak base, it ionizes in the aqueous solution partially. This is the major difference. Dear students, you will get question on this lecture in the upcoming exam. So please you will revise it. All of you know that this is my revision lecture. That's why I didn't discuss to the point very broadly. I just focus on the creative question only. So no more today and goodbye.